And welcome back. We've seen void functions, we've seen named functions with parameters, and we're going to take this little guy and just write him out just to show you once again how things work. And there we go. So what we have here is the same thing we've been having before. We're just going to print the little number out, run it to the screen, and there's our happy little 5. Now, if we wanted to, we could actually come down here inside our function and declare local function variables that exist only inside this function and add the number that we just passed to it. So we're going to print out the new number, just like that. So this says, give me a number, pass in the value, and make this guy run. And you'll see, there we go. We passed in 5. We started with 0. We have 5. If I give it 10, boom, I get 15. Now, if I wanted this number to constantly stay updated with whatever this addition result is, the only way that we have currently, until we get to the new stuff, is this concept of a global variable. So I can start off a number like, well, I'll start with 10 just to make it show and match. That if I don't declare it locally to the function, if I declare it globally, this will persist for every run of the program. So you can see it says 15, but if I run it again, so if I run it twice, you'll see it goes 15, 20. This global number exists throughout the whole piece of code. And if you don't declare it and you use it, it'll use this. But if you make a mistake, for example, and you forget to declare it locally here, this means that now this number is what's going to be used here and what's going to be used down here. You're going to get some interesting results. See, boom, 2040. What? That's not what I was looking for. So you have to remember that if global variables are impacted across the entire program wherever they're not masked out by a local variable. So if the local variable has the same name as a global variable, the local variable takes over until the end of the scope of that variable. This one would work from here to here. This one works from here to here. So number itself, as you can see by graying out, doesn't have anywhere to work. But that's what happens with global variables, which is why in our class we do not use them. Global variables are bad because they allow for all kinds of errors and debugging nightmares of trying to figure out what's going on. If you need a variable, declare it in the main function and pass it to the helper function to do its own little job. But what if we want this thing to stick around and stay for us? Well, there's a new concept now. It's called a static local variable. This static variable now says whenever you first run the print number function, declare a variable of type int of name number and don't destroy it at the end of the function. So this will persist. It's only available here. You can't use it anywhere else, but it will persist in the function forever. So if I have 5 and I pass 5 in, I get 15, and then I pass 5 in again, I should get 20. Boom, 15, 20. This actually sticks around. This is really useful for counters and other things that you want to know. How many times did I do something? Or maybe you only want to call something a few times and hey, how many times did that happen? 4 times? Okay, you only do it 3 more times. Now only 1 more time. When this gets to 0, don't do whatever this function's supposed to do. Pass back something else. So you can see that this static concept allows things to persist. So local variables and static variables solve the problem of global variables when you really don't need them. In the real world of coding, you might find yourself using them some, but it should be kept to a very, very small limit. Once again, remember, the code we're writing in this class is small, but if you had thousands of functions, the odds of you having the same name and making a mistake are exponentially larger. Now, something we can also do with this is we can actually declare for a function this thing called a default value. Right now we have print number called with a value, and if we try to use this function without something inside the parentheses, the code is going to go, hey, you're not doing this right. The default value allows you to declare at your function level, at the first definition of your function, which is for us the prototype, a value. If you stick it in, there you go. So if I have a default value of 10, that means that whenever I call this function without giving it something, it'll actually pass in a 10. And that means we should see 10, or should see 15, 20, then 30. Let's check and see. 15, 20, 30. So that 10 is what gets overwritten because I didn't give it anything. Now you can have multiple default values, but you can't space it out with things that aren't. You have to be careful with how you do this. The default values, for the most part, really should happen at the end of the function, because the default value says, I didn't give you something, use this. If you try to do this, it doesn't know which int you forgot. So it really, really won't let you do it. As a matter of fact, the compiler now even tells you, hey, you've declared default values up here, you're missing a default value here. But if I move these guys, just to show you what the error messages work, assuming they show up, that if I can come down here and I can do this, so that would give me default values that would work. So if I only gave it 3 integers, it would know that the fourth one was a 5. If I only gave it 2, it would know the third one is a 10 and the fourth one is a 5. If I give it 1, it's not going to have any clue what I'm doing. I can't, however, give it the first, the second, and the fourth, because it doesn't know which one of these I skipped. Even if I declare it by type, it gets confused. So this is just a cautionary tale. Try to keep these guys set so that you know what they are, and try to keep them to the end. I don't use default values very often, except unless I need to initialize something, but that's the whole purpose behind default values. So now you've seen global variables, we don't use them. You've now seen local variables and how they get scoped out by global variables. You've now seen static variables that can sit around and hang on to things for a while. And you've seen the possibility of default values just in case you want to run it with a common variable or a common size to things. And that is the nature of variables, scoping, global, local, parameters, and static. Hope you're having a great day.